Assalamualaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIVS Home School. I am Sabreena Haque, Assistant Teacher of Science, National Ideal English Mission School, Day Shift. Today I am going to take a chemistry class for class 9 student on the based on chapter 3, and this is the first part of our chapter. So let us move for today's topic. Dear students, today we will discuss chapter 3. The name of the chapter is Structure of Matter. Then first, we have already learned the structure of matter in class 7 and 8. Then have you ever thought what is the things around us made of? What your body made of? Yes, like you, ancient philosopher also think of these questions. The ancient Greek scholars used to think there are 4 basic elements: soil, water, air and fire. All other things according to them are made of these 4 elements. Greek philosopher Democritus was first to say all substances have a unit which is very small and indivisible. Dear students, here the name of Greek philosopher Democritus and the very small things which is indivisible, and he is called it in the atom. This is too much important for you for MCQ, and this however did not get any recognition as it lacked any specific proof. Finally, John Dalton, the British scientist, and we also learn about John Dalton's theory in class 7 science book, gave a theory on atom in 1803, which was based on data collected from various experiments. He said that every matter of the universe made of small indivisible particles. He honored the Greek philosophers by naming these particles atom. You have to underline this line because this is too much important for you. Later on, it was proved that atoms are not indivisible. Any atom can be divided into electron, proton and neutron, and this chapter will focus on various models of atoms, configuration of electrons, etc. Now come to the elements and compounds. The elements, certainly you have seen the gold, silver, irons, and when the divided the matter which does not yield anything but itself is called element. This is the definition of element. And besides above the 3, that means gold, silver, iron, there is also many other elements: nitrogen, oxygen, phosphorus, and so far a total of elements have been discovered. That means 118 elements have been discovered. Out of them 98 elements are available in nature. That means 98 elements are natural and rest are made in the laboratory. The second group is known as artificial element. That means the 98 elements known as the natural elements, and rest that is the which are rest elements known as the artificial elements. Now come to compound, and that means we already learned about the when we divided the matter, and after division if we yield anything not but itself is called element. But the substances which is divided give away 2 or more elements are made compound. That means if we divide the carbon dioxide, that time we will get carbon and oxygen, and if we divide the water we will get hydrogen and oxygen. That means there is 2 types of elements atom, and that's why this is called compound. The substances which if divided give away 2 or more elements are called compound. In a compound, element will be always exist in the same ratio. That means if you think about carbon dioxide, here carbon is 1 and there is 2 oxygen. That means there the ratio is 1:2. Then every time the ratio of carbon and oxygen in the carbon dioxide always be 1:2. It will be same. Now come to the atom and molecules. Atom are the smallest particles of the elements that contains the characteristics of the element. Just in the introduction of the chapter we have learned that we can divide the atom and we will get the electron, proton and neutron, but that time it will lost its characteristics of that element. For example, nitrogen atom contains the characteristics feature of nitrogen, while oxygen atom contains the same of oxygen. And when two or more atoms remain connected with each other in a chemical bond is known as the molecule. And when we are saying about the carbon dioxide, just now we have told about carbon dioxide CO2. That means here carbon and one carbon atom and two oxygen atom are in one molecule of carbon dioxide, and here they are joining through a chemical bond. It is known as molecule. And when more than one atom of a specific element bond each other, they produce the elements molecule, like O2. O2 is the molecule of oxygen, and when the atom of different elements bond together to produce a molecule, it is called molecule of compound, that means CO2. And come to the symbol of element. Dear students, the abbreviated form of English or Latin name of an element is called its symbol. That means here is written about English and Latin, but some of the elements name taken from the Arabic also. That means the abbreviated form of English, Latin or Arabic name of an element is called its symbol, each element has its own symbol, and there is a system of writing symbol of an element. The first letter of an English name of an element is usually the symbol of that has to be written using capital letter, like hydrogen H and oxygen O, nitrogen N, and the first letter is taken as the abbreviated form of the English name of that element. Now come to the second one, that means when the first letter of the two or more animal in the same and one of them is expressed by the first letter and the other elements get the first two letters, the first letter is capitalized and followed by the small hand second letter. Now come to this symbol of elements, first letter same, that means carbon. Come to carbon, carbon's letter is C and it is taken the symbol as C. Now come to chlorine. Here the C also, chlorine also started with C, but the symbol becomes the Cl, not the H, because here along with C the L pronounced, and that's why the L is taken as Cl, and it is the symbol of chlorine. Second one is calcium, Ca. Third one is cobalt, Co. Cadmium, Cd. Chromium, Cr. Here all the name start with C, but only carbon has the symbol C, and the rest of them get the two letters, and first will be written in the capital letter and next letter will be small letter. And the third rule, some elements have got their symbols from their Latin name. If you see this chart, all the elements got their symbol from their Latin name, like sodium. Sodium's Latin name is natrium, that's why its symbol is Na. Copper's Latin name is cuprum, its symbol is Cu. Potassium's Latin name is kalium, its symbol is K. Silver's argentum, this is symbol is Ag. Tin, stena, its symbol is Sn. Antimony, stibbium, that is Sb. Like this, all these elements name get the symbol from their Latin's name. Now we will come to the formula. Only hydrogen molecule is expressed as H2. That means the formula is express the molecular position of the elements or compound. That means H2 is the formula of hydrogen, N2 is the formula for nitrogen, and if there is two kinds or three types of molecule, that also expressed in the in the molecule how many atoms are there, they are shows, that is the called a formula. That means ammonia, the NH3, there is only one nitrogen and 3 hydrogen atom, and chlorine Cl2, this is the formula of chlorine. Then sulfuric acid S2SO4, here 2 hydrogen atom, 1 sulfur atom and 4 oxygen atom in the sulfuric acid. This is the formula of sulfuric acid. And hydrochloric acid HCl, 1 hydrogen atom and 1 chlorine atom togetherly form the formula of hydrochloric acid. Now we will discuss about the particle inside an atom. Each atom consists of 3 stable particles: electron, proton and neutron. Proton and neutron remains in the nucleus at the center of the atom, while electron continue to move around the nucleus. Then come to this page, dear students. Here we can divide in the atom one kind of stable particles. There is so many unstable particles. Stable particles: electron, proton, neutron. Here electron is shows with the E, and proton shows with the P, and neutron shows with the N, and these are the charge of electron, proton and neutron. And there is so many unstable particles also, you will get it in the next classes. That means meson, positron, gravitron, there are also so many, that means neutrino, antineutrino, so many unstable particles are there. And come to again to the electron. Electron of one of the permanent particles of the containing negative charge, and the amount of this charge is minus 1.60 multiplied with 10 to the power minus 19 coulombs. It is expressed through the symbol of E. An electron has the mass of 9.11 multiplied with 10 to the power minus 28 gram. The relative charge of the electron is taken to be minus 1, and the relative mass of electron is 1 by 1840 of proton and neutron. This is why the relative mass of electron is taken as 0. Dear student, the relative mass of electron is negligible than the mass of atom, because atom mass is 10 to the power minus 23, and this is the mass of electron, and for that why it is so negligible and its relative mass is taken as 0, that's why. And come to the proton. Proton is one of the stable particles of an atom containing positive charge, and the charge of proton is plus 1.60 multiplied with 10 to the power minus 19 coulomb. And if you observe, the charge of electron and proton is same, just only electron's charge is negative and the proton charge is positive. That's why when we see when we observe an atom, this is neutral in charge, because the electron and proton number will be same in the atom. It is expressed by P. The mass of proton is 1.67 multiplied with 10 to the power minus 24 gram. The relative charge of proton is taken as plus 1 and relative mass is taken as 1. Now come to neutron. Neutron is another stable particle of an electron containing no charge. Neutron prevail in an atom of all elements except hydrogen, expressed by N. A neutron has mass slightly more than proton and its relative charge is 0 and relative mass is 1. Dear student, this is an important table for you for the MCQ and knowledge based question, and you have to learn this table, and it is so much important. I am saying again and again, these things we will need again in the next part of your chapter. Now come to the atomic number. The definition of atomic number. Atomic number of an element is determined by the number of protons presented in the nucleus of that element's atom. For example, atom of helium has 2 protons in its nucleus. So the atomic number of helium is 2. The atomic number denotes an atom. That means through atomic number we can recognize that atoms which atom we are getting in. Then if the atomic number is 1, we understand this is hydrogen, and the atomic number is 2, we understand this is helium, and if atomic number is 9, we understand it is fluorine. Thus the atomic number is the permanent identity of an atom. Then proton number or atomic number is expressed by Z. Since all atoms are charged neutral, so they contain the same number of electron and the number of proton in its nucleus. Now come to this picture. There, if we observe, this is red color, these are the electrons. There is 3 electrons, and these are the proton. That means we know the electron and proton will be same, that means 3 proton, and it will be add with neutron number 1, 2, 3, 4. There is 4 proton. That means here will be 7. And by seeing this, we can easily understand. Here, this is the nitrogen. The atomic number. This is the nitrogen. Now come to the next page. Page number 41, the mass number. The mass number of an atom is denoted by the total number of proton and neutron, and in its nucleus the mass number is expressed by A. That means atomic number expressed by Z and mass number expressed by A. Since the mass number is the summation of neutron and proton, we can get the number of neutron in any atom by deducting the proton number from the mass number. The mass number of sodium is 23, the proton number is 11, so the number of neutron is 23 minus 11 is 12. Here atomic number of an element is written in the lower left corner and its symbol, and while the mass number written in the upper left corner. That means if you observe that in the periodic table, the sodiums, this is the mass number of the sodium, it will be written in the upper left corner, and the atomic number, this is the 11, this is the atomic number, it is written in the lower left corner of the sodium symbol. Now by seeing this, we can easily understand which will be stay in the symbols upper left corner, with this, that will be mass number, and which will be written in the lower left corner, that will be the atomic number of that element. Now come, if that is H1 and 1 written, from here we can easily understand the symbol is H, atomic number will be here written 1, the mass number also here written 1, the number of electron, because proton is 1, electron number of electron will be also 1, the number of neutron 1 minus 1 will be 0. Now come to next one, that is H, here He, that means helium. Here in the upper side there is written upper left side 4 and their lower left side is 2, that means atomic number is 2 and the mass number is 4. Here the symbol is He and the atomic number is 2, mass number is 4. Now number of electron is 2, and if we subtract from 4 to 2, we will get the number of neutron, that means 2. Now here they give a task for you. There is lithium and beryllium. We have to find out the atomic number, mass number, electron number, proton number and number of neutron. Now we will solve in this page these things. First, here is symbol. First one, that is sodium Na. Atomic number will be 11 and mass number will be 23. Number of atomic number and number of electron will be same, that means 11, and number of proton and atomic number will be same, that means 11, and number of neutron, if we subtract 11 from 23, we will get 12. The number of neutron is 12. Now next one, that means hydrogen. Here atomic number 1, mass number 1, number of electron 1, number of proton 1. If we subtract 1 from 1, it will be 0. Now helium, there the atomic number is 2, mass number is 4, number of electron that will be here because proton and this also will be here, that means 2, and from this 4 we will subtract this 2, we will get the neutron number, that means 2. Now come to lithium, this one, and here atomic number is 3, mass number is 7, electron number is 3, proton number is 3, and if we subtract this 3 from 7 we will get 4, that means the lithium's proton number is 4. The next one is beryllium, Be, symbol is Be. Beryllium's atomic number is 4, mass number is 9, then number of electron will be 4, number of proton will be 4, and if we subtract the atomic number from the mass number we will get 5, that means number of proton will be 5. Now next one is carbon. The atomic number is 6, mass number is 12, number of electron will be 6, number of proton will be 6, and if we subtract 6 from the 12 we will get the number of neutron also 6. Like this way you can find out any elements, electron number, proton number and neutron number from its atomic number and mass number. Dear student, this is your homework number 7. You have to make five knowledge based question answer from this part of the chapter, and you have to submit on Saturday from 9 am to 3 pm. Dear student, I have finished my today's topic. Hope you have understood this chapter is too much important chapter and you have to read this again and again because so many information you will get that will be important for next chapter 2, and this is the basic chemistry. So read more and more and do the SW regularly, submit it regularly. Thank you. Allah Hafiz.